This is Module 3, Lesson 4, where we are going to start proving figures are similar. Now, the standard is 8GA4. We're going to understand that two-dimensional figure is similar to another if the second can be obtained from the first by a sequence of translations, reflections, rotations, and dilations. Okay, now let me say this. We've already done this, but we did it with congruent figures. Remember how we proved that two figures were congruent? By using translations, reflections, and rotations to map them on top of each other. Well, now we're going to do the same thing, but if a figure is similar, we're going to have to dilate it first and then use translations, reflections, and rotations to get them on top of each other. So today we're going to prove that two figures are similar by describing a series of congruence transformations and dilations that prove their similarity. This is from Eureka, Module 3, Lesson 6. Okay? Now, this is actually, there's some problems here in your packet that we're going to start with. The packet is actually in On Course. If you look on in On Course under Resources, you will see Module 3 packet, and you can find these things here. This is on page 5 of that packet, okay? Or actually, not page 5. This is on, not page 5, but you're going to have to go several pages down because I put everything in here, come to think of it. Everything we've got here is in here. Go down to Module 3, Lesson 4, and it'd be the second page underneath it, okay? Those who have a paper packet, it's on page 5. Now, if I'm looking at this figure, first we're trying to decide whether images are congruent or if they're similar. Let's look at these figures. Do they look congruent? If you'll take your patty paper and draw this one off, see what you can do. And if you do that, you're going to find that you can slide it right over here on top of this one. A slide is a translation. And remember, whenever you describe these things, you've got to tell me where you start and exactly what you do in very much detailed sort of a situation. If I take this figure, and I know I'm starting with this one because there's no tick marks on it, and I translate it right, that's 1, 2, 3, 4, 5. That A would be right here, wouldn't it? Then if I translate it down 1, 2, 3, 4, it would put A right on A prime. If you do that with patty paper, you'll see that these are exactly on top of each other. They're the exact same size and shape, so they're congruent. So I translate triangle ABC 5 units right and 4 units down. And that's all I have to do to prove that they are congruent. I've mapped them on top of each other. They're the same size and shape. What about this second one? Well, draw it off, and on patty paper, rotate it around. On this one, I rotated it 180 degrees around the origin. You got to tell me what you're going around. When I did it, put it right where you see this red triangle. Okay, so what I actually needed to do then was translate it over one, right? Translate it 1 unit left, and that would put them on top of each other. So that's the description right here. How about this figure, NOSE? Well, let's see, this is only 2 units from the y-axis, 2 units there. So if I draw this on patty paper, and I draw these 2 axes, draw my center, and then I reflect it over, I will find they're right on top of each other. That means they're congruent, same size, same shape. All I had to do was reflect figure NOSE over the y-axis. How about this one here? Well, you can't reflect it because that would put this pointy thing down, and the pointy thing's on this side, the P's on this side. However, draw this on a piece of patty paper, and if I rotate it 90 degrees clockwise around the axis, around the origin, I'm going to put these 2 right on top of each other. They would be the same size and shape. So to prove the 2 congruent, that means same size and shape, I would rotate figure PEN 90 degrees clockwise around the origin. Okay, that would map it, those 2 on top of each other, and prove they are congruent. How about 5? And remember, guys, we've done this before in the last chapter. We're just reviewing. I would take figure mouse. Okay, it's 1 unit. S is 1 unit from this x-axis. If I reflect it, it's going to put it over there. It would put the whole figure there. Draw it off on patty paper, reflect it over the x-axis, and you see that the 2 of them are right on top of each other. They're the same size and same shape. So this would involve reflect figure mouse over the x-axis, and that maps them on top of each other and proves they're congruent. But 6, these two are not congruent. These are not the same size. They're not the same size. They are the same shape, just not the same size. How can I map SAE on top of S prime, A prime, E prime? Well, if they're the same shape but not the same size, then they are similar. This one is going to be that we're going to prove figure SAE is similar to S prime, A prime, E prime. Figure SAE is similar, not congruent, to S prime, A prime, E prime. Okay? This thing here means it's similar to. Now, how can I do that? First, I need to know the scale factor that is involved here. How much bigger is my image than my pre-image? I know this is my pre-image because there's no tick marks on it, okay? This is the one I'm starting with. How much bigger is the image than the pre-image? Let's compare two sides, or you can compare two of the corresponding points, but I'm going to compare the side lengths, A to E. Let's see, we know that scale factor is the image over the pre-image. The length of this image side, and I'm using these sides because they're on grid lines and easy to count. This side is 1, 2, 3, 4, 5, 6, 7, 8 units long, okay? All right. This side is 1, 2, 3, 4 units long. 8 divided by 4 would give me a scale factor of 2. Okay, so I've got a scale factor of 2. What does a scale factor of 2 mean? It means the image is twice the size of the pre-image. Now, how would I find where the coordinates would go? Remember when we were dealing with coordinates and we were dilating them? Okay, well, if I start here at S, which is at 0, 2, and I dilate by a scale factor of 2. That means I multiply each of these by 2. 2 times 0 is 0. 2 times 2 is 4. So this one will be at 0, 4. 0, 1, 2, 3, 4. S prime. Okay? How about A prime? Let's see. A is at -2, -1. Okay? So A is at -2, -1. If I multiply that by 2, A prime would be at -4, -2. Okay, so that's at -1, 2, 3, 4, -2. How about E? E is at 2, -1. If I multiply 2, -1 by 2, it would be 4, -2. 1, 2, 3, 4, -2. Okay, that is how I map one onto the other. I have proven them similar. I dilated figure SAE by a scale factor of 2 with the origin as the center of dilation, okay? Now, what about these figures, okay? These two I'm proving congruent, not similar because they're the same size and the same shape. All I'd have to do would be rotate QRST 180 degrees around the origin, draw it on your patty paper, rotate it around and see if that's where it goes. How about H? I can prove these congruent, okay? Translate figure home, this is the original, up 3 units and left 7. I need to put the H on top of the H prime, not on the O prime. And I can prove that these two are congruent because they're the same size and same shape, okay? What about proving these two are similar, right? Let's look at this scale factor. Let's find the scale factor of the two because they are the same shape, not the same size. Okay, the image side, let's compare this one, is 8. The pre-image is 4. 8 over 4 is 2. The scale factor is 2. So let's see. If I've got n, which is at 0, 0, and I multiply that by 2, I still get 0, 0. It didn't move. Let's see. I is at 1, 2, 3, 4, 0. If I multiply that by 2, that would be at 8, 0, okay? And that's where I prime is. F is at 0, 3, and if I multiply that by 2, I get 0, 6, okay? So this is indeed a dilation. A dilated triangle FIN by a scale factor of 2, using the origin as the center of dilation, okay? And then let's try this one right here, all right? If I start with this figure here, let's see what their sides are. I counted this side as 4, this is 12. This is the image, that's the pre-image. 12 divided by 4 would give me 3 for my scale factor. Okay, so let's try each point and multiply by 3. This point is at -2, +2. That would be -6, 1, 2, 3, 4, 5, 6, and then up 6, okay? And check all your other points, guys. All I did was dilate triangle SIT by a scale factor of 3 from the origin, okay? Now, we've proven some of these are similar. We've proven some of these are congruent. These here on this next page are a little more complicated, and if you want to try them, you can. I just left that in there for practice if you wanted it, okay? That's all we're going to do on this particular lesson. We'll do some more proving that these things are similar in the next lesson.